All right, Algebra 2, we are in lesson 63. That means this lesson and one more, and we're done for this semester. I'm so excited. All right, let's get this one down. We're going to learn how to add vectors together. So you remember vectors. We learned how to do those. Those are on a coordinate map where we have a length from the origin and an angle here that tells us where this point is. It's not about the x and y coordinate, but the length of the distance from the origin and the angle that distance is located at, right? So that's a vector. And the way we designate that vector, or the way we determine that vector, is by turning it into a right triangle and then measuring the degrees from a starting point on the positive x-axis. That's 180. And then let's say if this were 30 degrees, then we'd say 180 plus 30. That would be a 210 degree rotation of the vector. And then, so we would write it like this. The angle is 210. And let's say the length is 12. So you'd have 12 by a 210 degree angle. That's our vector, right? So we understand what that is. What happens when people change vectors, or vectors directions change? Even if you're just walking somewhere, you walk in one direction for so long a period of time, and then maybe you take a right and you go in another direction for so long a period of time or so long of a distance. That's what we're fixing to do. We're going to see how to add those together. So first we need to look at this, we need to look at this problem to learn how to do that. This is 63.1. Now, this problem says that Flying Arrow left the village. I'm guessing Flying Arrow is his Native American name. He left the village and traveled 20 miles on a heading of 20 degrees. Okay. From this point, he traveled 40 miles on a heading of 210 degrees. How far from the village did he end up? So first we have to write out our vectors. Our first vector is 20 miles at an angle of 20 degrees. Easy enough. Our second vector is 40 at 210 degrees. Okay, so that's easy enough. You just look at it and you write the length and the angle. The length and the angle, the length and the angle. Those are our two vectors. Now we remember that when we break up a vector into components, one component is going to be the sine of the angle, and the other is going to be the cosine of the angle, right? So we have to find the basically the r and the u component for each one of these vectors. So let's draw that out. So we know that a 20 degree angle, because of how the coordinate map is, it starts measuring it here. It's going to be in here somewhere. It's going to start here. So our triangle, the right triangle, is going to be here, right? This is the x-axis. So that's our vector. So this is 20. It's the hypotenuse. The length is the hypotenuse of the triangle. And the degree of measure is right here. It's this angle. It's the one closest to the origin. So that's 20 degrees right there. What we don't know are the two legs. And we're going to label that N and E. Those two legs are what we need in order to find our location. And if you look at the map, it's almost like this is north, this is south, this is east, and this is west. So up is north on here, on this map, and then to the right, the angle to that direction, it's going east. So this is a northeast vector. And that's why we labeled up with an N and the bottom leg with an E to represent that northeast direction. How many units north, or how many miles north and how many miles east, is where this point is. Okay, So let's do that. So first we have to find the sine is going to be, all right, SOHCAHTOA, you have to remember, SOHCAH, and we're not going to use TOA, so we don't have to write it. I just like the poetry or the iambic pentameter or whatever it is. It just kind of rhymes and sounds good. SOHCAHTOA. So we don't have to write it. I'm not going to write it. So the sine is the opposite over the hypotenuse. So the opposite here is going to be n over 20. So the sine, n, we need the 20 times the sine of the 20 degrees. And this is the hypotenuse times that, right? How did we get to this point, Miss Tracy? That makes no sense. Let me back up. We know that SOHCAHTOA is the sine of the 20 degrees, right, equals the opposite over the hypotenuse, which is 20, right? If we multiply both sides by 20, right, you see that cancels. So that's how we got to that first step. We just reversed it. The property of symmetry says we can say n equals 20 times the sine of 20 degrees. So that's what we started with. We just skipped this step because we knew we could do that. But if you have to do this first to wrap your head around what this should be, then do that. It's okay to take that extra step. All right, so now we just look on our calculator and we type in the sine of 20, and that's going to be, I've already done this ahead of time to save some seconds, that's going to be 0.34. And when we multiply that out, we get a 6.8 is what n equals, right? So this one is 6.8 right here. And then we do the same thing for e, and e is going to be the cosine, which is the adjacent over the hypotenuse. So what we end up doing is we multiply the cosine of 20 times 20, right? Because of this same principle that we did here. So we're going to say 20 times the cosine of 20 degrees. And the cosine of 20 degrees is 0.94. And when we multiply that by 20, we get 18.8. So east is 18.8. All right. So now we need to do this vector. Now that we have these leg measurements, let's do this vector. So we know on the coordinate map that this is 180, so we have to go below to get to 210. So we'll draw it a little bit differently. We're kind of in the crux here of the coordinate system. We started here, 180. So 180 from 210, that's going to make this right here, about 30 degrees, like that. And we draw it up, and that becomes there. So we do the difference. So this is going to be 30. We don't want to do 210. That's a really big number. We want to reduce our numbers as much as possible. So we just do the size that we really need to do. We can't do that whole semicircle. So we cut that out and we just do the part that's relevant. That's relevant to the axis that we have. So we are going to do the same thing, only we're going to, since this is on this side like this is going to be south because it's headed south, and this is going to be west because it's headed west, right? And our length here is 40. Right, so just like we did over here, our north and south, that's going to be our opposite of our angle. South is going to be opposite of our angle. So we're going to use our sine. So S is going to equal 40, which is the hypotenuse, times the sine of 30 degrees. And the sine of 30 degrees is 0.5. And when we multiply that, we get 20. So S is 20. Now we're going to do the west, and the west is going to be the cosine, and the cosine is the adjacent side to the angle. So W is going to be 40 times the cosine of 30 degrees. And the cosine of 30 degrees is 0.87. And when we multiply that out, we get 34.8. So west is equal to 34.8. My pen is not doing right again. There we go. All right, 34.8. So now we have all of the ingredients we need to turn this into a system of equations that we can add algebraically so that we can figure out what his final vector ended up being, okay? So let's do that now. Let's look at the first one here, the direction he first went, and we know that I hit the wrong button. This is to the right. This is right here, so it's to the right, right? So it's going to be 18.8 R. And then this one is up. So this is going to be plus 6.8 up, right? Now this one, the second one here, it's to the left on the Cartesian coordinate system. So everything here is to the left and it's down. So everything is going to be negative. So we do the same thing. We do the x-axis first. That's going to be the west. So it's negative 34.8 to the right, minus, and now we do the down. So that's going to be the south. So it's going to be minus 20 U. And I'm going to go ahead and put 0.0 here just because this already has a decimal and I want it all to line up. All right, so now we combine those. So looking here, when we combine negative 20 and a positive 6.8, we get a negative 13.2 U. And when we bring down our sign, because it's the negative was greater right there, now we can bring down our R, and then we can combine these. And when we do that, we get negative 16 R. All right, so now we know how to plot our vector. So he ended up 16 miles west and 13.2 miles south of the village. And we know that because this is negative and this is negative. So he ended up 16 miles this way, so about halfway here, and then 13 miles, so somewhere in here is where he ended up. So you could actually go and plot that and then create a new vector. All right, so we are going to do that again. Wasn't that fun? Let's clear our page, and I am going to type it out for you because my handwriting is atrocious. All right, that didn't take long because it wasn't a word problem this time. This time they just told us point blank what to do. So 63.2 says to add 30, a vector of 30 at a 55-degree angle and 10 at a 170-degree angle. So let us do that. So first we have to figure out the two triangles and what we have. So I like to have my little map over here as a reference, just so I can kind of see it, right? So let's do the 30 first. So we have a 30-degree vector, or a 30 length vector at a 55-degree angle. So 55 is going to fall within this 90 degree, right? So 55 is going to be a little bit more than half because 45 would be half. And 30 is kind of long, so it's going to be steep. So it's going to look something like this when we draw it out. Okay, and we know that this is 30, and we know that this is 55. That's all we know so far. And we know that this is going to be north because it's going up right here. That's where this one is. And this is going to be east because it's along the x-axis on this side. So that's this one. It's right about like that. Okay, so now we do the same exact thing we did before. We solve for n, and we say 30 times the sine of 55 degrees. That's going to equal oh goodness, they didn't give me the sine of 55 this time. 55, the sine is 8.82. So 30 times 0.82. I keep hitting that button. I wish it would stop. And that equals 24.6. All right. Now, sometimes these are going to get hairy, just like anything else that we round. When we round up, so my sine was actually when I did 55 and I pressed the sine button, it was actually 0.8191. So I rounded it to 0.82 because that makes sense, right? But if you don't round it and you leave it in your calculator and then you just multiply that straight times 30, I get 2.57, which is 24.57, which still would round up to 0.6. So it just depends on how exact you want to be. I have no problem with rounding. And if it's, like I said, if it's close, if it's within a couple hundredths of the decimal, I'm going to mark it right. Okay, it's just the system may not do that in the process. So just, trust me to find it and catch it. I'm going to evaluate your answers. All right, so that's north. And because it's north, we know that that's going to be positive r, right? Because it's going up. And the east one is the cosine because it is along the x-axis. And it's going to be using the adjacent angle. That's why we do the cosine. So we're going to say 30 times the cosine of 55 degrees, and the cosine of 55 degrees is 0.57, and it's actually 0.573, but I'm just going to stop at 0.57, and I'm going to say 0.57 times 30, and that's going to give me 17.1. So it's 17.1, and we know that that is to the, did I do this backwards? I did. All right, this is up. North is up. 17.1 is to the right. Okay, now we have our things in order. All right, so that will be our first equation. I'm going to put it right down here. We are going to have 17.1 r plus 24.6 u, right? Because north is up from the x-axis, and this is right on the x-axis, okay? So let's do the other one. Let's do 10, and I'm going to draw my little sign here so I can kind of see where it's supposed to be. 170 degrees. That's not quite all the way, right? So this is 90. So this is going to be 80, which it's going to be easier to use the 10 degree because it's going to be a smaller number to use. So let's use it. So it's going to be like that. So our triangle is going to be 10 long and 10 degrees. So it's going to be a small triangle. Let me see if I can, I'm just going to erase it. I'm going to draw it a little bit bigger though. So it'll be like this and like that. Because this is 10 degrees and then this is 10 on the hypotenuse. And we need to figure out because this is on top, this is still north, but this is going to be to the west. Okay. So this one's going to be positive and this one's going to be negative when we finish. So let's do the same thing we did before. So north is the sine, because it is the opposite over the hypotenuse. So that's going to be 10 times the sine of 10 degrees. All right, and then the sine of 10 degrees is 0.17. I keep hitting that stinking button. So 10 times 0.17, which we can do in our head, becomes 1.7. All right, and we're going to do W here. So that's going to be 10 times the cosine of 10. And the cosine of 10 is 0.98. So 0.98, which is just going to be 9.8 because we are just moving the decimal point back one. All right, and this is going to be to the left. It's going to be negative. So we're going to turn that into a negative, and that's going to be negative r because it is along this x-axis. And this one is up, so it's going to be a positive u. All right, and it really helps to remember the quadrant coordinates here. In this quadrant of our coordinate system, our x is negative and our y is positive. So that's why we have a negative for the x-axis and a positive for the y-axis location, right? This is the x, this is the y. So that's one of the reasons why we learned that when we first started doing the Cartesian coordinate system, so we could get this right. So now we put them in order. Let's go ahead and stack them. Negative 9.8r plus 1.7u. And now we can combine them. And we get, that's going to be 13, carry the 1, that's going to be 6. So 26.3u plus, and then our r. And we have 17.1 minus 9.8. That's going to be 7.3. So 7.3 to the right plus 26.3 up. All right. Now, if we round the sum of the vectors to 2 decimal places, we get, well, I've only got 1 decimal place. So if we round it to 1 decimal place, this is what we get. And we can then put that into a tangent form where we can then turn it back into a vector. So let's do that. Let's do our tangent form. So we have we can draw our triangle here. 7.3 to the right. All right, it's positive. And then we're going to have up 26.3, right? So it's probably more like this. All right, and then we can figure out what our hypotenuse is. That is our length using Pythagoras' theorem. Or we can use the tangent. And the tangent is going to be, we don't know the degree of the angle yet, so we just put that little symbol in there to take its place. The tangent is going to be the adjacent over, no, the opposite over the adjacent, right? And this is the degree of measure that we are looking for here, right here. That's what we want to know. So we want to find 26.3 over 7.3. Sometimes I have to stop and think about it for just a second. And that is going to give us the degree of measure here. So we're going to have, let me get my calculator. 26.3 divided by 7.3 is 3.6. And if we put that into our inverted tan, that gives us a degree of 74 degrees. All right, and our vector, our hypotenuse here, we're going to find that out by doing the old-fashioned way. A hypotenuse measurement is also found using the distance formula, and that is both of our measurements squared added together and the square root taken, which is the same thing as Pythagorean's theorem, just done a different way. So 7.3 squared plus 26.31 squared, right? And that ends up being the square. Ooh, I didn't mean to draw something. I just paused too long. My dog keeps moving around, driving me nuts. So that ends up being 7.3 squared is 53.29 plus 26.31 squared. Where did I get 26.31? All right, I got that from the book. Sorry. 26.3 squared is what number we used. So 26.3 squared is 691.69. We add those two together. We get 744.98, and we take the square root of that, and we get 27.29. And the reason we need that is so we can do the length here to do another vector. So I'm going to round that up to 27.3, and then our angle of vector angle was 74 degrees. And that's our new vector after adding all of that together. All right, so we take our vector, right? Step one, we kind of draw it out so we can see what we're doing. We figure out where it is on our coordinate system. And once we place it, then that tells us whether which side is up and down. Excuse me, I could feel that coming. So once we get our little sketch, we can kind of see our adjacent and our opposite angles. It's a lot easier to figure out which one is sine and cosine. So we set that up. We solve for the up and we solve for the right on both of these. We solve for the up, and in this case we had to solve for the left, which is just the negative right. Okay, then we combine our results into one vector by adding them together. Then we take that vector and we turn it into a triangle. We pick a dimension here and we solve using tan because we don't have our degree of measure, so we can take the two sides over each other to find our degree for this angle. Then we take these two measurements and we square them both and add them together, and then take the square root of that, which is what we would do in Pythagorean's theorem anyway. And it gives us the length of our hypotenuse. And that, having the length and the degree of the angle, allows us to then create the new vector of where they ended up, or what the result is of these two vectors added together. All right. So if you have any questions about this, please feel free to ask. You must use your calculator. Okay, you've got to use your calculator for sine and cosine. There's no way that you can just do all this in your head. If you don't have a calculator, please, please, please get one or borrow one. And I will see you guys in lesson 64, which is the last lesson of the semester, because this lesson is over. Ta-ta for now.